Right, so in year 11, you're more likely to get a little bit harder factorising quadratic question. So there's sort of a lot of rules around what we do when we're factorising. So the first thing we always should do when we see a quadratic, that's something with an x squared in it, is look for a factor that can be taken out of all the terms, a common factor. So there were no common factors in the ones we did in the previous lesson, because it started with x squared, so we knew that. So we're really looking at the number in front of the x squared to see if we can take some or all of it out. Today we're going to be taking all of it out. All right, so we've got this one. Okay, so we can't take x's out because there's no x here. What number will we take out? Correct. 5 is the common factor. So we're going to take 5 out and look at what is left. Now we've put it in brackets, so is it factorised? Perhaps, but not all, definitely not most of the time. Most of the time we need to put this in the brackets as well. So we need what multiplies to give 1 and adds to give 2. There's only one thing in the world that multiplies to 1 and adds to give 2. And it is 1 and 1. You're right. So our answer is 5, x plus 1, x plus 1. Sometimes when we have a repeating number like this, we can write it as x plus 1 squared. All right, so we introduced perfect squares. So what do they look like when we're factorising? We probably need to look for them. So what we're looking for is when we have two numbers that multiply to give this and add to give this that are the same. So what is the number here? What is the square root of this number? Yeah, so 4. And 4 and 4 add to give 8. So we know that both of the factors are the same. We've got 2 of these factors. That makes it a perfect square. All right? Perfect because the factor is squared. Okay? Then we've got something that's called a difference of squares. So a difference of squares we looked at when we were multiplying out, but when we're factorising, we have to know to look for this particular example. Oh, this can't be a quadratic. There isn't any x term. Of course it can. All it needs is an x squared term. So we've got an x squared term. We need to actually find out what makes the middle term disappear. So two numbers that multiply to give negative 16 and add to give nothing, 0. So that means if they add to give 0, they must be the same, but one must be a positive and one must be a negative. So multiplying to give 16, or the square root of 16, is 4, and adding and subtracting 4 means nothing. So let's have a look what that looks like. Adding and subtracting 4. X squared, take away 4x, add a 4x means nothing, and we get negative 16. So when that middle term is missing, we don't take an x out because there's no x here. It's not a common factor kind of example, it's a quadratic kind of example. All right? So we could have these muddled up as well. We could have a question with a number in front of the x squared that we'd have to take a common factor out. But we should always think in our heads, can we take a common factor out? Yes, we can. Let's do that first before we factorise. Otherwise, the problem gets really difficult. Let's have a look at just one more of a common factor. Hopefully this one works. Let's have a go. So, we need to take a common factor out of 36, 14 and 2. Generally, we look at this number and it's probably that number. So, 2 out leaves x squared plus 7, because 7 times 2 is 14, minus 18. All right? What multiplies to give negative 18 and adds to give positive 7? So, 18, 1 18's 9 2 6 3. To give 7, 9 twos. How do we get positive 7 out of 9 and 2? Right, positive 9 and negative 2. So that's going to be our answer. 3 parts, the common factor and the 2 bracketed factors. Okay.